Hello everyone, it's AStar Games. Today we will be making our player go to the point we click on the world. On the previous tutorial I have showed how you can add AStar logic to your game for pathfinding, and I have used that project and converted into this version where player goes to the point we click. If you haven't watched that video or don't have any experience with AStar with Defold, I would strongly recommend you to watch it before you start with this video, because I won't explain the AStar logic part in this video. I will show how you can change and make your player go to the point you click. There are two main things you need to change. One is of course the player script, because player will not be controlled by keyboard this time, but it will go to the point where we click. And also on the camera, we need to set it to orthographic projection, otherwise it won't work. And if your game looks too small when you start it, you need to set the zoom to a higher value like this. I have added a new Lua module. For this, right click, new, and Lua module. Name it camera. I have taken this code from Defold. I think there is the link here. So I won't go over it, but what this basically does is to take the mouse click on the screen and convert it to world coordinates so we can use it. On the player script, we require AStar and the camera, of course. We have a speed value. We have the tile size which will be used on the AStar. We have our direction name which we use with the animations. And there is the last position vector we will use to calculate which direction we are going towards. We have two methods. One is to screen to coordinates and the other is to coordinates to screen. I have explained this in the previous video. We enter a position on the screen to this and it gives us some coordinates, and this does the same but in reverse. On the init we acquire input focus, because player should be able to tell when we click with the mouse. And on this our self table we create a vector named move direction. This part to the end is the generic code for the AStar. What you need to be careful with your game is to set the correct tile map and layer, again on the above as well. On the on input we check if the action ID is touch. If we go to input binding, we will see the touch action is binded to button left, so left click will activate it. Then I add another check to see if action is released. You don't have to add this part, but if you don't, when you click once, it will probably calculate this part 3 to 6 times, and we don't want that, it's unnecessary. So I check if the action is just released. Then I take the world X and world Y by using camera dot screen to world, and first variable is our camera's path. The second is our actions X value on the screen, and the other one is our actions Y value on the screen. Yeah, like this, and the Z value is 0 because we don't use it at all. Then we convert it into a vector, the X and Y value, Z again is 0. Lastly, we had the last click position vector, and we use screen to chords, which, as you can see, returns two values, 1 and 2. So last click's X and Y values are set here. Now the real magic is done on the update. We first check if we have clicked anywhere yet. If not, we will just return because we don't need to check for anything else. We create a local variable for our current position and use GameObject.getPosition to get our current position. And we use screen to coordinates to get the tile we are on and save it on the current position.x and current position.y. So right now our current position does not hold the coordinates we are on the world, but holds the tile we are on. This is the AStar logic. We first check if we don't have any target or the last point we clicked is far from where we are standing. Then we have another check. We first check if we have a valid current path or the self.target index is greater than 3. I have explained why this is necessary. If you don't add this and click so fast around, player will always be calculating and standing at the start point instead of moving towards the target. Then we use AStar.findPath, enter the start position and the end position we want to be on, and return it as a path. If path is valid and its size, using sharp before a table returns you the size, is larger than 0, that means we have a valid path, so we set the current path to the returned path value. We set the target index to 1 and the target is where it is on the world. Since we have our path after this, we first get our position, then check if our current path size is larger than 0, so it's not empty, and the target index is less than the current path's size. So we haven't reached the end yet. Then we create two local variables, next tile and next position. Next tile is the tile we need to be on, so we get it from the current path and use the target index to get where we want to be. We have the next position. We use the next tile and get its position on the world. We calculate our direction by subtracting the current position from the next position to get a vector towards the direction we want to go on. And we use GameObject.setPosition by adding the direction multiplied by speed and delta for consistency and move towards it. If our current position is only 2 units away from our next position, then that means we are close enough to the point to set a new point as our goal, and we increase the target index by 1, so we will go to the next point. There are these 4 lines which we use for animations. If you remember, we had a variable named last position above here, and since we are increasing the target index here, that means we still have the previous target index there. So we set it as the previous tile, then we use coordinates to screen to save the previous tile's position as our last position. After increasing the target index, what we do is a bit code repetition, but if you don't add this, let me show you. it does this weird thing. That's because at one frame, our player's previous tile and next tile is the same. To avoid this, we also calculate the next tile's position on the same frame. After that, we set the move direction, which we use to determine the direction we are going and set the animations by subtracting last position from the next position, the same logic. We normalize the vector, and here is the previously used movement animation logic. If our move direction dot y is less than 0, that means we are going down. So we check if our current animation is not down, then we play the down animation and set the direction name to down. So next time if we are still going down, we will know we have already started playing it. We do the same, but check for other directions, and if we are not moving at all, we play the idle animation. At the end, we set the move direction to 0, so we will be playing idle animation when we stop. And that's it. That's how you can make player go to the point you click on the screen. I will upload this project file to my itch.io page. You can go and download it from there. I will leave the link to that page on the comment section. You can also find the link to my previous AStar tutorial on the comment section. Thank you for watching and have a nice day.